Hello everyone, and welcome to Rational Science. Another day in physics, rational physics, compared to what they do out there. How are we different here? Well, we do physics with objects, and more specifically, we have something a little different than everybody else. Everybody else has all these little particles flying around, and we say that all atoms in the universe are interconnected, physically interconnected. Okay, so the rest of the world works with discrete particles. Even those who propose waves propose discrete particles. We propose an interconnected universe. All atoms are physically interconnected. They're not connected like, a fellow like Nassim Haramein. He says that atoms are connected, that we're connected, but he says, he proposes concepts. He talks about energy and who knows what. No, we're talking about something else. We're saying we're physically interconnected. And here's the model. They're physically connected by what we call the electromagnetic rope. It's a rope that interconnects any two atoms. And what we have there is that the rope is made of two threads. One thread loops around and becomes the electron shell. The other one goes straight through the center of the atom and constructs the proton. And when the atom does its quantum jump, it torques the rope. And that torsion, that's what we call light. Okay, and here's the construction of the atom so you can get an idea what I'm talking about. Magnetic thread goes around and forms the electron shell. The electric thread goes through, and that's the construction of the atom in a nutshell. There, all ropes from the universe converge upon our atom and construct our atom. Okay, so that's the basic model that we propose here. That's why all atoms are interconnected according to the rope model of light and gravity. And so the question is, what is the advantage of this? Well, with this we can explain the most common phenomena. We can explain light. It's a torsion, a 3D torsion, not a transverse wave, 2D transverse wave, or a longitudinal wave. No, it's a torsion along a rope. The rope is the physical mechanism that is torquing, and that's the signal we call light. And one advantage of that, tremendous advantage, is that we can explain gravity. Why? Because there is no such thing as action at a distance. The only reason for action at a distance from the mathematical establishment is because they can't see or touch the mediator. So they say, I can't see anything, like when I let go of the pen, right, goes down, always falls to the floor. And I can't see anything between the pen and the floor. I can't see anything between the pen and the floor. So, I put my hand there, I can't feel anything, I can't see anything. So people say, well, there's nothing there. Well, hopefully there's something there. Otherwise, we're doing physics with spirits. Okay? And so the notion that people have, here, let me give you an example. Here's an astronaut falling to Earth, right? They say, well, I can't see anything between the astronaut and the Earth. So clearly, gravity is, who knows, some kind of magic. There's nothing there. And how do we illustrate this? Well, we illustrate it like this. We're saying that the astronaut is connected. Every atom in his body is connected to every atom that comprises the Earth. As he falls, the ropes fan out. And as they fan out, that explains, that is the cause, that is the mechanism for acceleration. Okay, so that's essentially the model. And again, we can explain it with this rope model, with a rope, every atom being connected to all others. Some people say, well, I can't see the rope and I can't touch it. And so this is what the hang-up is. People can't see or touch it, and they say there's nothing there. And that's when we have to go into the words something and nothing. And this becomes an issue of definition. People want to dismiss that as semantics, as, well, I didn't come here to learn English, grammar. I came here to learn physics. Well, unfortunately, people don't know what an object is, and we had to define it. No one defined it in the last 10,000 years. And so this is where the problem starts. I mean, you would think that a physicist would know what an object is first, and that we would have a definition in the books. And it turns out there's not a single textbook of physics, so-called physics, high school or college, that defines the word object, that tells you what something is, what an entity is, what a thing is. And this is incredible. After so many thousands of years, no one really defined the word object. More important than that, no one realized how important the word object is for the purposes of physics. You can't do physics without an object. That's the first principle of physics. And nobody realized that either. So we start out, these people don't realize that they need an object to do physics. And because of that, they never bothered to define the word object. And so we had to do that. We had to lay the foundations of physics because nobody can. Nobody did. Okay. And so let me see if I can get this thing here. And so here, this is what an object is. An object is that which you can touch or see. Okay. And there are objects we can't. I'm sorry, an object is not that which you can touch or see. That's the version from the establishment. Okay. And we can't touch a tri-bar and we can't see the air. So obviously, are we going to say these are not objects even though they're made of atoms? So what are these? What are we going to, and they say, well, these are concepts. Well, this is where the problem starts. So this is the mathematical version of an object. It's that which you can see or touch, and that means that you're going to observe it, okay? Or you're going to touch it. You're going to do some kind of experiment. And that's where the see-touch criteria comes from. That's also where the observer and experiment enter into so-called the scientific method, which we call the mathematical method. It's got nothing to do with the scientific method. What is the scientific method's version? Well, here we have it. If I can find it. I think it's this one. No, that's the one I just showed. Well, let me continue. Anyways, this is our conclusion for what an object is and what the observer is and whether we need experiments in science. Do we need to observe anything? No, in science we have the mafia principle. Okay, mafia principle of science. Kill the observer. We do not observe and we do not do experiments. Why? Because we're not going to detect through experiments what light is, what gravity is. Mother Nature, God, Father Universe, the devil, one of those guys, they made light and gravity specifically invisible and intangible. And so we're not going to detect them by going through the lab, doing an experiment. We're not going to do it through observation. We're going to do it only by visualizing. You have to think, how could Mother Nature be doing this experiment? You got to visualize the mechanism. That's what we do here, and that's what how we're different than everybody else. Okay, and talking about nothing and something, something and nothing, today we have two fellows. One is Richard Dawkins, which we've been looking at in the last couple weeks, and the other fellow is Lawrence Krauss, Larry Krauss, and I did a little bit of a bit on him, a vid or two some time ago. So now we got these two fellows together. Let's see what they have to say about something and nothing. Well, who are these two fellows? Well, here's their bios, okay? Just a quick bio on them. We covered Richard Dawkins the other day. He's from Oxford University and became a born-again atheist after he read Russell's Why I Am Not a Christian, okay? And he wrote a book, the most popular, I guess, from his hand, and that's The Selfish Gene. And yeah, the shellfish gene sold quite a bit, and I can see why. You know, that's the cover of the book, I think. Yeah, I can see why he sold books, quite a few of them. This other fella, Lawrence Krauss, he also, he comes from MIT. He's a mathematical physicist, meaning he's not a scientist. And here, this is what he wrote, Universe from Nothing, subject of matter of today. And at the bottom you see I have focused on either the creation of something from pre-existing empty space or the creation of empty space from no space at all. Okay? So so this is what we're going to discuss today. Is it possible, or does it make any sense, or is it part of physics to say that this universe, matter, came from absolutely nothing? And you can even put God in there or take God out. I don't care. The question is, can you make something from nothing? Can God, with all his superpowers, can he make something from nothing? And these guys dispense with God. They say, no, something came from nothing directly. Okay? Self-made. Okay? Self-made universe. Okay? And so, in fact, this fellow Larry, he wrote a book on this issue we discussed last time. And you see it there. I circled it. It's Why Are We Here? So-called physicists, these mathematical so-called physicists, they are talking about why are we here? Was there a reason, a purpose? And I guess they're suggesting, or he's suggesting here, that not the why of philosophy, but the why of physics, the cause mechanism. And that's what we're going to talk about today, what the cause, how matter came to be. And these two fellows, just in case, because remember they have a lot of authority behind them. Yeah, they have a lot of medals. Okay, you see all these medals that these guys have on their lapels. And so, this guy was awarded, what is it here? Andrew Germant Award, or Gemant Award, Lilienfeld Prize, Science Writing Award. So... yeah, they won a few beauty contests here and there. They get their bouquets and cry down the hall with their flowers. Well, I'm the most intelligent guy on earth. I've been blessed. Okay, but this guy, Larry Krauss, he's a little more famous for something else lately, and that's that he was accused of sexual misconduct. And here's the bit. He was working at Arizona State University, and he was accused by several girls of, touching their boobs or something, or I guess maybe they have sensitive boobs, I don't know. And some of this, you got to wonder about. I mean, this guy, he looks like a geek, four-eyed geek. I have trouble believing that he's a sexual predator, that's me. And I wrote a piece sometime back on in Quora, and I have some doubts about some of these accusations. Here's one of them against this fella, Harvey Weinstein. And he was accused by Rose McGowan, an actress. And this is in 2007, after he allegedly, fondled her, raped her, or whatever he did to her. I don't know what he did to her, but this is some years later. And so, I don't know how many girls go out there with their rapist, to the parties. So I don't know. These accusations sometimes, you have women who are who are gold diggers, and you have men who overstay their bounds, overstay their stay. So you've got on both sides, and unless the girl goes directly to the hospital and has herself checked out, it all becomes hearsay in a court of law. So who knows what happens there? So I don't know about the accusation against Larry, but what struck me was not the sexual part that was in the article. What struck me is the other stuff. He will remain on paid leave, drawing a salary of $265,000 until his retirement in May, the university said. And it turns out that he eventually came out of there. This is an older article, and he's getting, not only did he get a good salary, he got a good retirement. And for what? For teaching your kids that the universe comes from nothing? Is that what's worth 265 grand? And I want to make a point that Arizona State University is part of, they receive funds from the federal government. Here's another article, the bottom half of that picture there says, Arizona State University will get the highest amount of any college in the country. And it was made by, because of this coronavirus thing. And they will receive 63 million in total, half of which goes to the kids who, financial aid to students, but the other half goes to the university itself. So this is a publicly funded university. You're paying for it with your tax dollars. You're paying this guy's salary, $265K, to teach what? That the universe comes from nothing? Think about that next time you pay your taxes. Okay? So yeah, I got a little bit of problems, not with his sexual misconduct. I have problems with his salary. I think this guy is not worth $10,000 a year. But let's find out. Let's find out what his argument is. He's going to propose, that something comes from nothing. Okay, so let's find out. And he gets into a talk with Richard Dawkins, and they start off on the wrong foot, okay? Because this is what they say. Here you have Rich on the left and Larry on the right, two of the stooges that are left from the three, I guess, right? The whole point about modern physics is that you can't do it by common sense. Whoa! And that's why you need physicists, okay? And Larry says he gets upset because it is the illusion of knowledge that upsets me the most. I think he's talking about the so-called mathematical physicists, that they have this illusion of knowledge. They say they know, and then they tell you stuff like this, that they can't do it through common sense. So let's investigate this. What do you mean you can't do it through common sense? I mean, we got a little bit of problem if we're going to use uncommon sense to do physics, right? I thought physics was common sense. And in fact, if you look up, I've shown this in the past. Here's good old Richard Feynman, and he just tells you flat in your face. I think I can safely say that nobody understands quantum mechanics. Do not keep asking yourself if you can possibly avoid it, but how can it be like that? Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. They've given up on that. They don't try to make sense of it anymore, just like Dawkins and Larry Krauss just said. They don't try to make sense. And, this fellow was Nobel Prize in 1965, I think. He's dead, so you say, well, that's over. No, here's one guy that's alive. He says the same thing. His name is Leo Susskind, and he's at Stanford University. He says, modern science is difficult and often counterintuitive. Where intuition and common sense failed, they had to create new forms of intuition, mainly through the use of abstract mathematics. When common sense fails, uncommon sense must be created. Human cognition does not operate according to principles of common sense. Okay? So they all agree. All these guys are on the same boat. They say, look, don't try to make sense of physics. We've given up on that. We're not even trying anymore. We're not trying to make sense of it. We're not trying to explain exactly how this universe works. But then they do explain it with some, irrational explanation, some irrational mechanism, one that you cannot even visualize. Particle being in two places at once. Four-dimensional space-time in the case of relativity. And then they tell you, well, we're not supposed to make sense of it anyways. It's beyond our brains. Well, maybe their brains, yeah. We can make sense of it. We can make sense of it very easy. Our rope model matches The equations, as far as I can tell, I don't see any violation between the equations and the rote model. And we don't have to produce a new equation. We can use the equations that's always been there. We just give a different physical interpretation to what these people do with particles. The problem is the particle hypothesis. That's the problem. That's what you can't explain with. That's what you can't explain, how Mother Nature does her stuff with particles. That's where the problem is. And instead of abandoning the particle, instead of applying Popperian falsifiability and saying, well, I guess all experiments falsify quantum mechanics, instead of that, they created idiotic principles, the principle of complementarity, uncertainty, and so on, or Einstein's principle of equivalence, which I've covered in the past. Anyways, what these people do is just work around the falsifiability. That's all they did. Instead of saying, well, it falsifies our theory, let's go back to the drawing board, erase it, start over. No, they said, let's continue with particles. And that's where the problem is. There are no such thing as discrete particles out there in the world. And once we abandon the particle hypothesis, then we can make some progress, perhaps, right? Okay, so they continue, and here's a little chat between them. Larry says, the key idea, which is so difficult and I guess challenging and threatening to both some philosophers as well as theologians, is this question of something from nothing. It happens in the case of biology. How do you get life from non-life? Well, getting life from non-life is not exactly getting an apple from absolutely zip. So it's not the same question. It's not the same issue. The analogy is not correct, okay? Getting something from nothing is very fundamental. It's just something that goes to the root of everything. How did things come into being? That's different than saying you got a process where inanimate life became living. That's a different issue, okay? Here we have a process, and you just got to figure out a process. You can even start it with God and his magic wand if you want. I don't care. But the point here is that saying that something came from nothing is a totally different ball game. So that's not a good analogy for that question, okay, for that issue. Rich says something from nothing, from literally nothing. Yeah, whatever that means, right? That's what really gets people. Yeah, no kidding. It got me for sure, okay? That's really counter to common sense. Yeah, hey, Rich, you got it. They clearly misunderstand what you mean by nothing. Okay, I'm sorry, I misunderstood. Please tell me what nothing is. Please define the word so that we're all on the same page, okay? And yeah, in rational science, space is nothing. Vacuum is nothing. That's what nothing is. What is nothing? Well, we have a definition for it, that which has no shape, okay? So here it is. I think this is what I was looking for before. Okay, put it over here. Okay, what is something? Well, we had to define these words because no one in mathematical physics, so-called physics, ever defined what an object is or what nothing is. So we had to do it for them. Something, that which has shape. Nothing, that which doesn't have shape. Straightforward. Now these two words are antonyms, and we can use them consistently, rationally, in any dissertation. We know what nothing is. We know what something is. Something is the opposite of nothing. And nothing is that which has no shape. So we're looking, when you stare at the night sky and see all that black stuff there between the moon and other stars, well, you're looking at nothing. What are you staring at? You're staring at that which has no shape. And that's why it's black, because it doesn't reflect anything to your eye. Very simple. That's why the night sky is black, partly. Okay? There's no reflection in space because space is nothing. If you have doubts, just go ask an astronaut. See if he scrubs his elbow, scratches his elbow against space, against vacuum. No, they treat it as nothing, but then these theoreticians, they come in there and they say, well, no, you're wrong. See, nothing is really something. Yeah. Okay, and so they clarify, what's his name? Krauss. He does not define the term, okay, nothing. What he does is just tell you that, well, it's not. I'll tell you what it's not. And what it's not is the philosophical notion that we had all these years about nothing. The notion that came from the Greeks, essentially, okay? And so here he says the following. He says, I'm often accused of not talking about the nothing that classical philosophers 2,000 years ago, especially Greeks, right? Or theologians talked about. Okay, so what are you talking about? The answer is that I'm not really interested in their nothing. I'm interested in the real nothing. So we have the real McCoy and the false McCoy, okay? And he's going to deal with the real McCoy, the real nothing. I'm interested in asking the question based on our understanding of the universe. Okay, you have no understanding of the universe, so I don't know what you're going to talk about at this point. So science changes what we mean by words. Yeah, I have no problem with that. Change the word. Just give me a definition so I can follow your presentation, so that I know what you're talking about. Something and nothing are not theological or philosophical quantities. Yeah, for sure they're not. They are physical quantity. Physical quantity. Well, there you have a physical quantity. Is this a physical quantity, Larry? Number 5? Is that what a physical quantity is? What the hell is a physical quantity? If mathematics is all abstraction, and abstraction is exactly the antonym, the opposite of physical. So we have a contradiction. A physical quantity. It's a physical abstraction, or an abstract physical. Or again, they invent all these notions, and all it is word wizardry. That's all it is. Most people recognize that something is a physical quantity. Well, I don't know who those most people are. Huh? Maybe in mathematical physics, yeah. But they refuse to accept the idea that nothing might be a physical quantity. Yeah, for sure. Somehow the absence of something. I don't know what he's talking about. He's talking about ones and zeros. One is a physical quantity, and 0 is a non-physical quantity. I don't know what he's talking about. The guy just is shooting a lot of words, and he was talking in front of a crowd that included at least a lot of people who were just laymen. So the onus was on him to say, look, let me tell you what I mean by nothing and what I mean by a physical quantity. Who knows what a physical quantity is in the religion of math? Okay, so I guess this is what he's referring to, okay? What Dawkins replied to him. Clearly the idea that you can start with nothing but the ordinary laws of chemistry and end up with us and kangaroos and oak trees and wombats, that is the most astonishing fact. Even more astonishing is that you can get physics, you can get matter, you can get everything from nothing. Well, so far I have no idea what these two individuals are talking about, okay? Because all they did was just make statements. You know, I mean, was this just a small talk? I thought we were going to have like a science talk there. I would learn something. And all we have is statements. They just say, well, it is so. Something came out of nothing. And now they're going to prove it. In 2 seconds, they're going to come in there and tell you how this something came from nothing, but they never defined the word nothing. I want to make absolutely clear that they went directly into proofs of their theory that something can come out of nothing, but they never defined nothing or something. Neither one. Okay? So this is important to keep in mind. Okay? So here we go. This is what Larry says. He tries to explain something, gives an example. He says, quantum mechanics, for example, defies common sense. No kidding. That's why it's garbage. That's why it's not part of science, because it defies common sense. You said it. The most uncommon of senses. Common sense. Everything that we think is sensible about the universe is not true. Oh. First of all, true is an opinion. So that's his truth. Okay? So he's just giving you his version, his opinion. Okay? You and I appear to be in one place at one time, but electrons can be in many places at one time. Yeah? Has he bought into this? After 10 years of studying, getting a PhD, this is what he says, that an electron can be at 2 places at once. This is his knowledge. This is what he passes on for $265,000 a year to his students. My God. I'm almost starting to believe in God again. It seems impossible. Of course not. It's impossible. It seems illogical. Of course it's illogical. I have a t-shirt that says 2 plus 2 equals 5 in the limit of extremely large values of 2. Okay? That's his quip there, okay? The point is that 2 plus 2 in the limit of large numbers, common sense goes out the window. Yeah, because 2 plus 2 is 4. You got 2 apples here, 2 apples there, you got 4 apples. Where did you get limits and high values of 2 that give you 5? And once you add gravity to the mix, everything changes. And yeah, you have to remember that quantum mechanics has not been able to incorporate gravity into the particle model and never will. Of course they never will. They never will because you cannot pull with particles. You know, here you have 2 particles, 2 balls. You know, you can do this experiment at home. It's very dangerous, so do it always in the presence of a relativist, okay, or mechanic. And, you know, I try to pull with a ball. I try to pull this other ball with this ball, and it doesn't pull it. I don't feel any pull there. But you can try it. You don't believe me, go ahead and you try it. Quite unlike magnets, you know, magnets, that one pulls, okay? But balls, particles, unless they're magical, which is what quantum proposes essentially. And they can't even draw their atom because they can't explain, they can't tell you why the electron doesn't spontaneously fly away. Why is it bound to the nucleus? That's what they got to explain. And if they can't explain that, they don't have a model for their atom. And I'm talking about the simplest atom. I'm talking about the hydrogen atom here. Okay. Okay. Let me continue here. This is what he says about energy. Okay, he says one of the things we've discovered about the universe that is so amazing is that the total energy of the universe could plausibly be precisely 0. Well, hopefully it's 0 because energy is a concept. So whatever energy is, whatever concept that is, it better be 0. There had better not be a thing called energy out there. So it had better be 0. You know, if you tell me apples, you say, well, I have 10 apples, 20 apples, 30 apples. But energy, you better always have 0 energy and 0 mass, no, those concepts, and 0 field, because we don't use concepts in physics. And of course, energy is just a concept. An undefined concept, by the way. It's like Feynman said, we have no idea what energy is. Well, it's a concept. That's why you don't have any idea what energy is. There is no is to energy. Energy is a concept. It's like saying we don't have any idea what grace is, the grace of God. Well, yeah, because grace is not a thing. God might be a thing, maybe, you know, but grace, his grace? I don't think so. And yeah, where did he get all this nonsense, Larry Krauss? He got it from this fella who died a couple years ago, Stephen Hawking. He says that the Big Bang itself, the universe is thought to have had 0 size and so to have been infinitely hot. He says there are gazillions of atoms in the universe, and he says, where do they come from? Well, the answer is that in quantum theory, particles can be created out of energy in the form of particle-antiparticle pairs. Okay, so they're talking about virtual particles. Virtual particles are magical particles. Magical particles are, one is a positive, the other one's a negative. When you have a negative particle and a positive particle of whatever kind, right, they come together and form nothing. And then that nothing can also separate into plus and minus. And that nothing is also a synonym of energy. So they use these words interchangeably to fool you, and so they say, well, it's energy. And what do you say? What is energy? Well, I meant it's nothing. And what is nothing? Well, nothing is that which, when it breaks up, it turns into positive and negative energy. And so you get the runaround, you get charges, you get nonsense that has nothing to do with physics. We want to see a physical object. Okay, that's the issue. And he says, but that just raises the question where the energy came from. Yeah, where did it come from? The answer is that the total energy of the universe is exactly 0. So now you know where Krauss studied, where he got this from. He got this from the previous generation that just told him, and he just memorized it and spreads it around. That's where it is. The matter in the universe is made out of positive energy. The gravitational field has negative energy. Okay, so we have gravitational negative and matter positive. Okay, in the case of a universe that is approximately uniform in space, one can show that this negative gravitational energy exactly cancels the positive energy represented by the matter. So the total energy of the universe is zero. There's your proof. There's your evidence. It's all math. Now, twice zero is also zero. Thus, the universe can double the amount of positive matter energy and also double the negative gravitational energy without violation of the conservation of energy. Okay, so that's what they're saying. When the universe doubles in size, the positive matter energy and the negative gravitational energy both double, so the total energy remains zero. The universe is the ultimate free lunch. That's what these guys memorize and pass on to the next generation, which must mark, the letter D on the test, on the Scantron sheet, because, that's the one that says, when you have positive energy and negative energy, what do you get? You get zip, you get space, you get nothing. Oh, I see, okay. You passed. And when you pass, you get your degree. If you don't pass because you have a problem with that, and you say, well, I don't kind of agree with that, Get out of my class. Why don't you go into lawyering? Go into law. You're in the wrong class. So they kick him out, or the guy just goes into engineering or medicine or some other thing. He doesn't continue an irrational discipline. These guys are just memorizing this stuff and passing it on. They had no intellectual capacity to challenge that arguments, to challenge their teachers or professors and say, you're wrong, teach. They didn't have either the huevos, or the intellect, something they missed. And so these are the people that graduate and then pass on the same thing to the next generation. It's just on and on and on. They've been doing this for at least 10 generations. If 10 years, if you can say 10 years is a generation, we've had it for at least 100 years. I mean, quantum's been around since the 1920s at least, unless you include Planck, coming up with the quantum in 1900. Well, we've got 120 years of this nonsense. Okay, and so what is space made out of? See if I can get this thing up here. Space is made out of this, according to good old Larry. It's made out of virtual particles, positive and negative particles. And once that realization occurs, you realize that maybe there's a way to create something from nothing. Yeah, I mean, if you're going to do magic, you don't even need God. I mean, God was already quite magical, but you guys are getting rid of God. Poor God, he's being retired, going on Social Security or something. And so these guys got rid of God, but he says, we can still do the something from nothing, but we don't need God. And he said, well, we learned that the nothing of classical Greeks and of the Bible, an eternal empty void, is certainly not nothing. Okay, what is nothing? We still don't know what nothing is. Because empty space is a boiling, bubbling brew of virtual particles. There you have it. That's what empty space is. It's particles. And so the question for this gentleman, Mr. Krauss, and Mr. Dawkins as well, is what contours each particle? I mean, when they're forming space, you got a ball and another ball. I'll look at them as balls, okay, as spheres. So they say that these two come together and somehow form nothing. I can't do it with the balls. I'm not a magician, not in their sense. They say these two come together and form nothing. Okay, so they form nothing. What does nothing look like? And that's an important question, because I need to know the shape of nothing, because we had two balls. There's two shapes in front of us. Now they're going to come together. What's the resulting shape? They say it's nothing. Okay? You never defined the term. All you're saying is that we have these positive, negative, virtual particles, positrons and electrons. They come together, great. And they form nothing? Well, tell me what nothing is. What did they form? Because that's the issue is they form a something called nothing. I need to know what that something called nothing is, what it looks like, or what did it form? What's a new shape? And they say, well, it disappeared. Well, what do you mean it disappeared? What does disappear mean? See, you need to get down to that definition. And of course, under rational science, that which doesn't have shape, we're done. Very simple. You can use it consistently. It's the opposite of something, something and nothing. Something is that which has shape, nothing is that which doesn't. We're done. These guys don't start there because their whole religion falls apart. Because all these people at the SLAC, Stanford Linear Accelerator, Fermilab, the Large Hadron Collider over there in CERN, all these people have in their tiny minds that they're particles in space. Where do they get that? They say, we run an experiment, suddenly particles pop in from the void. That's their conclusion. Why do they conclude this? Because they can't see, or touch for that matter, the invisible stuff. And so they're inferring indirectly through the collisions that space provided the actual, the added virtual particles that they need to make whatever they saw come out right mathematically. So that's how, space became a something. And again, if space is a something made of particles, I need to know what contours each particle. We're back to the ether. Bunch of particles, that's what it was from the days of the Greeks. It's always been a bunch of particles. They could never figure out what space is. That's one of the big problems, not only in quantum mechanics, but also in general relativity. And yeah, he says, in fact, we've discovered that the fact that nothing can weigh something. So they take space, they put it on the scale, and it weighs something. They weigh it. How do they do that? Well, they do it through this mathematical trick. They turn energy into mass. That's how they do that. They say, well, we had so much energy. We had so many. I work with kilo electron volts. These guys work with tera electron volts nowadays, so just more so-called energy. Fine, it's the same process. They accelerate the so-called particles, okay? And so they say, well, how much energy does it take to accelerate a proton? How much energy does it take to accelerate an ion, a gold ion, for example, and so on down the line? They say, well, we need so much energy. And when they see the collisions, all that stuff, they say, well, we had more energy than we needed in there, so the rest came from space. Space provided the extra energy. And they turn that energy immediately into mass, and they say, oh, there's a mass there, there's a particle there. This is more or less their line of reasoning. Okay, this is what's happening in all these accelerators. They're white elephants, they are monasteries, they are cathedrals, that's all they are. Make no mistake, okay? Okay, and so again, he doesn't define, Krauss doesn't define nothing, but what he has to do is he has to belittle, he has to throw aside what the Greeks came up with, the notion that we've had all these years. Okay, and so he says, because it seems like you should violate some law, as a philosopher said, Parmenides. Out of nothing comes nothing, nothing comes. Okay, yeah, that's rational. Okay, these Parmenides was more or less in the ballpark logically and rationally, but these guys, I don't know. The interesting thing is that it's based on common sense. Yeah, it's based on common sense, which you don't have, Larry. But as you point out, the world doesn't care about our common sense. The universe doesn't care about our common sense. We have the wrong common sense as humans. See, our common sense doesn't match the universe's, Father Universe's common sense, God's common sense, the devil's common sense, Mother Nature's common sense. It's our common sense that is skewed, corrupted. Well, our common sense should be determined by reality, by the evidence of reality. Well, I don't know about his reality. I don't know how many drugs he's got in his system. So here's my answer to his, the universe doesn't care about our, which, by the way, Susskind already says, they say our logic, our rationality doesn't match the universe, Father Universe's rationality and logic. Okay, that's their argument. Well, here are my counter arguments to that argument. Okay, so you can take it from here. Here's Father Universe. Who told Larry that Father Universe has to conform to his uncommon sense? I mean, does this fellow think he's representing Father Universe? Is it possible that Lucifer doesn't agree with his explanation? Did Mother Nature bless Larry with the authority to interpret how she runs her shop? And does Larry claim to be God's messenger on earth? Is he willing to go on a cross for this notion that nothing turns into something, and that he's representing Father Universe's or God or the devil's version of how the universe runs? I mean, who elected him as a representative of these fine people here? He thinks he's representing the world. He says, I represent the universe, and this is the gibberish that I propose. And you say, well, that doesn't sound rational. Well, because your rationality doesn't match Father Universe's. So who told him that his rationality matches Father Universe's? In fact, I think that if Father Universe, God, Mother Nature came down here, I think they would crucify him for sure. They would ridicule him. They would say, you studied 10 years and this is what you came up with? Okay, summary conclusions. Otherwise, I'll take all year talking about this guy. Okay, if I can get this thing up here. And so here they are. Rich and Larry claim to be atheists. They don't believe that God created the universe. They believe in the universe self-creation. They think that the universe self-created itself. But they don't even believe that, because they're saying there was something there before the Big Bang, before the universe self-created. And that's, there were particles. Oh, there were particles, yeah. There were positive and negative particles, positively charged, negatively charged, gravitational, negative gravity, positive matter, whatever you want to call it. There was something there. Okay? And they say, no, it was nothing. Oh, it was nothing. What do you mean nothing? Yeah, see, you put them together, we create nothing. What is nothing? Well, nothing is the union of two virtual particles. That's what nothing is. Well, so far you have two particles, they had shape. Now you put them together, they still should have shape, unless you can tell me how they lost their shape, how length, width, and height suddenly became nothing, no length, width, and height. That's what you got to tell me. What's the process? Please explain the process, how the mechanism, how 3D becomes 0D. That's what I need to visualize. And you have to do it in 0 time, because it's from one frame of the universal movie, to use that term, to the next frame. So suddenly in this frame you have nothing, and in this frame you have something. So it's got to be done in 0 time. Not even God can do that. Okay? So what does he do? Well, he fails to define nothing rigorously. He never defines it. He just says it's positive and negative particles put together. That's all he says. Changes the traditional notion of nothing, because otherwise he's dead. So he's got to change the philosophical and biblical notion, at least the commonsensical notion that people have, whether you call it biblical or philosophical, I don't care. I'm saying the common notion that people have is nothing is nothing. What is nothing? Well, that which has no shape. That's what nothing is. There's your definition. Deal with that, Larry. Can you come with 2 balls and create no shape? 3D turn into 0D? We need the process. Okay, then we'll believe in your theory. Insinuates that nothing is made of particles that annihilate. Nothing equals plus ball minus ball. And the corollary is, well, human logic rationality does not coincide with Father Universe's logic rationality. Our human rationality does not conform to his rationality. No, I'm not saying my rationality conforms to God's or to Father Universe or Mother Nature or the devil's rationality. I'm saying your rationality is what's at question here. It's his rationality that's in question, not Father Universe's. So he's claiming indirectly insinuates that he's representing Father Universe when he says that. He's saying, oh, we know, we're mathematicians. We do all these equations. We know that this is the way the universe runs if you use particles to simulate that. Okay? That's the issue. And what happens is that these people come up and tell you that as if it were truth, as if they were representing Father Universe. That's where the problem is. I'm not saying Father Universe's logic is equal to mine, because I could be irrational as well. Maybe what I'm proposing doesn't match what how he runs the universe. If we call that truth, then my stuff could be false. That we can accept. But he's saying that his stuff is truth, even though he can't imagine it. And when you say, well, your stuff is ridiculous, it's surrealistic. He said, well, yeah, because your common sense doesn't have to match, not my common sense. He says it doesn't have to match Father Universe's common sense, meaning that he's the messenger. He was sent by God. That's what he's saying.